Good day, students. Today, we are going to look at calculations involving equation. Remember, we discussed mole in terms of the definition of mole. We looked at the definition of mole. We look at the three formulas that are very important for your level. We look at the three formulas of moles that are very important for your level. Today, we are going to use these three formulas, but in another form. We want to involve equations this time. We want to look at it from equations. How do we use these formulas in equations? Solving formulas involving equation. I have already written some examples down, some questions here for you, as usual, and I'm going to look at this question one after the other, and I will remind you what formula you will use. And number one question here is that an excess of silver nitrate solution was made to react with 2.7 grams of aluminum chloride. 2.7 grams of aluminum chloride in the equation AlCl3 plus 3Ag. You can see the equation, I already balanced it. But in this type of reaction, when you are given any equation in chemistry, to work with it, to work with an equation, when you are asked to work with an equation in chemistry, the first thing you have to do is to balance the equation. The first thing you have to do is to balance the equation. Balancing this equation, I've already balanced the equation for you to make our work easier. Now, but you need to know, of course, you already know how to balance equation. Now, name the type of reaction. Name the type of reaction. This type of reaction, of course, you remember that whenever you have two soluble salts, this is aqueous and this is aqueous, and an insoluble salt is coming out from it, an insoluble salt and another soluble salt. So this insoluble salt will now come out as a precipitate. Remember this when we're talking about making salt, making insoluble salt. This type of reaction is what? Can you remember? Good. Precipitation reaction. Two insoluble salt giving one soluble salt. That is just like a revision for you. What mass of silver chloride will be produced? This is our aim today. We want to solve questions using equation. Let me bring back this equation like this. AlCl3 aqueous plus AgNO3 gives us also aqueous, gives us AgCl, which is solid, plus Al bracket NO3. You know how to write these things now. Balancing our equation, of course, we had 3 in front of silver nitrate, and 3 in front of silver chloride. We'll go back and put our 3 here. And 3 here. This balances our equation. This balances our equation. Now, looking at this equation, I have 1 Al here, 1 Al there, 3 chlorine there, 3 chlorine there, and 3 silver here, and 3 silver here. Nitrate, I have 3 of them, and nitrate, I have 3 of them there. Everything is balanced. Now, the thing you are asked to do in this question is that they are asking you that you have been given 2.7 grams of aluminum chloride to start with, and you are reacting it with what? With excess of silver nitrate. Excess of silver nitrate. So, what amount of silver chloride will be produced? What mass of silver chloride will be produced? Mass of silver chloride that will be produced. So in this equation, you are given aluminum chloride. You are given aluminum chloride, and you are asked to find what? You are given aluminum chloride, and you are asked to find silver chloride. Everything in the equation does not concern you after balancing the equation. Those two things, what are you given? What are you asked to find? What are you giving? You are giving this. What are you asked to find? You are asked to find this. All other things are irrelevant to you now. How many mole of this do I have from the equation? The way the equation is naturally. This, I have 1 mole here. Naturally, I have 3 moles here, but it does not concern me because I'm not doing anything with this now. And I have 3 moles here. Naturally. 1 in front of this, 3 in front of this, 3 in front of this. But because this and this, I'm giving this and I'm asked to find this. All other things I don't care for now. So I've been asked to find 1 and I've been given 1. So this is 1 mole here. But was I giving 1 mole in the experiment? I wasn't giving 1 mole. I wasn't giving 1 mole. I have been giving 2.7 grams. So I need to find how many moles I've been given, because I know naturally it's supposed to be ratio 1 to 3. If I'm giving 1 mole of silver aluminum chloride, I should form naturally 3 moles of silver chloride. If I have 1 mole of aluminum chloride, naturally it is 3 moles of silver chloride that should be formed. So what do I do now? Now I look for, but I have not been given 1 mole of aluminum chloride. I've been given 2.7 grams of aluminum chloride. 2.7 grams of aluminum chloride I've been given. This 2.7 grams of aluminum chloride, I convert it to mole. Remember how to get mole from mass. Remember our number of mole equals to given mass divided by molar mass. Given mass divided by molar mass. What is our given mass here? Our given mass of aluminum chloride is, we are given 2.7 grams. 2.7 grams. 2.7 grams we have been given. What is the molar mass of aluminum chloride? Molar mass of aluminum chloride is mass of aluminum from your periodic table, which is what? Mass of aluminum from your periodic table, which is what? Is 27, which is 27, okay? Plus mass of chlorine multiplied by 3. That means MR of silver chloride is equals to 27 plus, of course chlorine is 35.5, so a common one, multiplied by 3. This gives us what? This gives us what? 35.27 plus, bracket open, 35.5 multiplied by 3, bracket close. Our answer is what? 133.5. 133.5. 133.5. So I have that the molar mass here is 133.5. It will be better for you to write this one quickly before I clean it. 133.5. This is the given mass, this is the molar mass. So what do I do now? I clean this and represent my thing there. So I have 2.7 divided by 133.5. For me to know the number of mole in my experiment, it's not 1 mole I have in my experiment. So when I know the number of mole in my experiment, the number of mole of silver chloride that will be formed must be 3 times that, because naturally it's supposed to be ratio 1 to 3. Aluminum chloride to what? Silver chloride. So this will give me what? 2.7 divided by 133.5. 133.5. My answer is 0.02 moles. 0.02 moles. This is 0.02 moles. 0.02 mole of aluminum chloride is what I've been given. If I am giving 1 and it gives me 3 of silver chloride, if I am giving 0.02, I will also multiply that by 3 here. So that means I have 0.02 multiplied by 3 of aluminum chloride. So this is as easy as ABC. You must have written this one down by now. You must have written this one down by now. Now I have 0.02 mole of this. Since it's ratio 1 to 3, 0.02 that I've been given mole, this will be 0.02 multiplied by 3, which is 0.06 mole. I have 0.06 moles of silver chloride. But my question is asking, what mass of silver chloride will be formed? So now that I know how many mole of silver chloride will be formed, I do the same thing. From mole, I'm looking for mass. This is as easy as ABC. Write this down before I clean it again. Write it down. You can stop your system or stop your computer and write it down again. So sorry, stop your video and write it down again. Now, can I clean the board now? We now know that 0.06 moles of silver chloride will be formed. 0.06 mole of silver chloride. So again, number of mole equals to given mass divided by molar mass. Given mass divided by molar mass. I have 0.06 and I'm looking for given mass. And I know the molar mass of silver nitrate. What is the molar mass of silver chloride? Molar mass of silver chloride, let's look. Silver is what? What is silver? This is not very clear. What is silver? 156 or so. 156. I need to check from a book. 156. I need to check from a book. Silver is 108. Sorry, 108. So I have 108. This 3 does not concern you. Just use the main thing. 108 plus 35 point what? Plus 35.5. Plus 35.5. 108 plus 35.5 will give me what? 108 plus 35.5 gives me 143.5. It gives me 143.5. 143.5. This gives me 143.5. So 143.5, which is MR of silver chloride equals to this. So now I have this. What am I looking for from my question? From the question, I'm looking for the mass. So what do? I cross multiply. So if I cross multiply, I will get my mass there. So that comes handy. Cross multiplying means I now say M equals to 0.06 multiplied by 143.5. 0.06 multiplied by 143.5. 0.06 multiplied by 143.5. Now let me do that. 0.06 multiplied by what? 143.5. 143.5. This gives me 8.61 grams. 8.61 grams. This gives me 8.61 grams. So if I have 2.7 grams of this, I'm going to produce 8.61 grams of silver chloride. As easy as ABC, step by step. First thing, balance your equation, then know the normal mole ratio. Pick only the 2 things we are asked to talk about. You can see now we have a reactant here. We are given a reactant and we are asked to find a product. The next one I will give you now is when you are given you are given a reactant, you are asked how much of the other reactant will react with it. So that's the next one I will talk about now. So let me write this down and let me clean it. Pause your system again and write this down. Okay. Now let us now look at another calculation. Question number 2. Now I have chromium 3 oxide and I'm reacting it with aluminium to give me aluminium oxide plus chromium. What type of reaction is this? Aluminium, of course, from what you can see in the equation, is more reactive than chromium, so it displaces chromium from chromium oxide to form aluminium oxide, and we are here producing chromium as a solid. We are producing chromium here, so you can use aluminium to produce chromium from chromium oxide. Now you have been given, so chromium can be manufactured on a large scale using aluminium metal as shown in the above equation. calculate the mass of aluminum required to react with 1 ton of chromium oxide. Now we need to react 1 ton of chromium oxide. Of course, 1 ton of chromium oxide. Let us write the equation again. I have Cr2O3 solid plus Al, 2 of it, gives me Al2O3 plus 2Cr. I think this is solid. This is what I have on the other side. This is what I have, my equation on the other side. So what do I do now? I have been given 1 ton of chromium oxide. How much aluminum will I react with it? Will be required to react with it to give me what I'm looking for. The natural equation, though, that's what they are looking for now. I've been given 1 ton of chromium oxide. I've been given 1 ton of chromium oxide. So I have 1 ton of this. The equation, I've already balanced it for you. So chromium oxide, I have 1. What am I interested in here? That's the only first thing you need to know. And what are you interested in? You have been given chromium oxide. And you are looking for how much aluminum will react with it. You are looking for how much aluminum required to react with it. So you do not need anything here. So only the reactants. You are given one reactant and you are asked to find how much of the other reactant will react with it. Unlike the first calculation, you are given a reactant, you are looking for how much product will be formed. So this one, from my equation, naturally 1 mole of this will give 2 mole of this, to give 1 mole of this and 2 moles of this. But these two guys, we don't have anything to do with them because our question does not involve them. So our question involves chromium oxide and aluminium. So now we have been given 1 ton of chromium oxide, 1 ton of this guy, 1 ton of this guy. This 1 ton of this guy is the same thing as 1,000 kilograms. 1,000 kilograms of it. And 1,000 kilograms, when you are working in chemistry, I told you earlier, you need to convert all your mass unit to grams. So 1,000 kilograms to grams. How many grams make 1 kilogram? 1,000. So you multiply by another 1,000. 1,000 multiplied by another 1,000 gives me 1 million kilogram. 1 million grams. 1 million grams of chromium 3 oxide. 1 million grams of chromium oxide. So this 1 million grams of chromium oxide can now look for the mole, number of mole. So mass of chromium oxide now, mass is this. So MR, we need to know the MR. If we know the MR, then we can now use N equals to given mass, which is 1 ton, divided by molar mass. Let's look at the molar mass. Let's hope it will be clear here. I still have the periodic table in front of me here. Let me just quickly open the periodic table here. Chromium is, because it's not clear here, chromium is 52. Chromium is 52. If chromium is 52, I can now say an oxygen, of course, we know is 16. Mr is 52 multiplied by 2 plus 16 multiplied by 3. 52 multiplied by 2 plus 16 multiplied by 3. 52 my bracket 52 multiplied by 2 bracket close plus 16 multiply another bracket open let me cancel everything. 52 bracket 52 multiply by 2, bracket close, plus, bracket open again, 16, multiply by 3, bracket close, and my answer will be 152, 152, 152, 152. So the total answer here is 152. I now have my number of mole of chromium oxide, which is 1 million is the given mass, divided by 152. 1 million divided by 152 again. 1, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Divide by 152. And my answer is what? The answer is 657, 6578.94. 6578.94. 6578.94. 6578.94 moles in one ton of chromium oxide. This is what I get as the number of moles. But the amount of aluminium I need to react with it, judging from our normal equation, the amount of mole I need to react with it has to be 2. If I have one of these, this must be 2. So if I have this, I have to multiply it by 2. The amount of aluminium I will react with it has to be this multiplied by 2 also. Since naturally the equation states 1 to 2. So this is also, if this is that, this will be this multiplied by 2. So my aluminium, you can write it down before I clean it. Write it down before I clean it. Okay. My aluminium now will be so since I have ratio 1 to 2, the number of mole of aluminium now will be 2 multiplied by 6578.94. if this one is 6578.494 moles. So 2 multiplied by this is what? 2 multiplied by 6578.94. This gives me 13157, 13157, 13157.88 moles. So this is the number of moles of aluminium that I require to react with 1 ton. To react with 1 ton of chromium. So that ton of chromium, I took it to mole first. Then I multiply by 2 because it is naturally 1 to 2. So when I multiply by 2, it is not the number of mole of aluminium. It is not the number of mole of aluminium that I want. It's not the number of mole. I've been asked to calculate the mass. What mass is the question they are asking me here is what mass. So I have to take that mole to mass. Convert that mole to mass. So I have to convert that mole to mass. I have to convert the mole to mass. So that number of mole, I convert it to mass, of course, by using my equation again. So I have this amount of mole, N equals to given mass divided by what? Divided by molar mass. So, and I have this one, N is 13157.88 equals to M divided by aluminium is what? Is 27 from your periodic table. Al is 27. I check again here because that is not clear. Al is 27. Thank you. Now Al is 27. I have now 27 here. So the mass that I will require, if I'm looking for M here, you know the normal thing to do mathematically, I cross multiply. So M equals to 13157.88 multiplied by 27. 13157.88 multiplied by 27. And my answer is what? 3,5 355 262 355 262 point what? 355 355 262 355 262 355 262.76 0.76 grams. 0.76 grams. This is the amount of aluminium that we add to chromium oxide to give us in this reaction, to make this reaction feasible, to consume the entire 1 ton, to consume the reaction, to use the entire 1 ton of chromium 3 oxide. Do you understand this? Is there any problem with this? If you can balance the equation, know the mole ratio of the two things involved in the question, every other thing will be okay. Do you understand this? Now let's look at another question. The question I'm going to look at now involves two equations. It involves two equations. Now I have manufacturing of calcium hydroxide involves two steps as shown in the equation. Calcium carbonate solid, which is limestone, is heated, and of course, what type of reaction is this? This is breaking down to form two smaller substances. This is decomposition. If you you can go to the video of types of reaction. If you are a Cambridge student, you should know this. But if you are not a Cambridge student, just know that the composition. Okay, we'll talk about this also later. Now, calcium oxide. This calcium oxide produced here by heating. This means heating. Remember this, heating. By heating calcium carbonate limestone, I have calcium oxide solid and carbon dioxide gas is given off. Now this calcium oxide solid, I now add some water to react with it, and I get what I'm looking for, calcium hydroxide that I'm looking for. I get what I'm looking for, calcium hydroxide that I'm looking for. So I'm manufacturing this. I've manufactured it now in two steps. First, I form this from this, and this one that I form, this one is given off. If I don't want it, leave it to go to the air, but this is dangerous. Remember the atmospheric effect of this. So you can trap it and use it for something else. So, but I don't need it to make my calcium hydroxide. So I only need this. So this that I need, I add water to it, then I get calcium hydroxide. For me to be able to make this process efficient, I need to know how much of this do I need, and how much of this will I decompose to form this. And once I've made this, how much of water will I add to it so that I don't have add too much water? You see, there is no room for wastage in science, so I don't add too much water. So what do I do now? Two steps. They say calculate the mass of calcium oxide form. The first step is easy for you now. Calculate the mass of calcium oxide form. What have you been given? You have been given how much? From 1 ton of limestone. So you have been given, let me write the equation again. Of course, it's balanced. Calcium carbonate solid plus, it breaks down to give calcium oxide solid plus CO2 gas giving off. So now I have, from my normal equation, I have reached, what am I looking for in the first question? First question, I'm looking for calculate the mass of calcium oxide formed from 1 ton of limestone of calcium carbonate. So I am interested in calcium oxide and limestone calcium carbonate. So I am interested in this and this. The other, I don't have any problem with it. In my normal equation, 1 mole of this produces 1 mole of this. But I've been given 1 ton of this. So what is the mole of 1 ton of this? Again, N equals to given mass divided by molar mass. So this gives me what? This gives me now 1 ton, of course, we know is 1 million grams. Divide by, what is the MR of this? I think it's about 100. This is 40 plus 12 plus 16 times 3, which is 48. 40 plus 12, that is 52, plus 48, that's 100. That's 100. So I have 100. That's a common one. Every teacher knows that. That's 100. I put 100 here as my MR. And of course, I do not need calculator here. This cancels this, this cancels this. So what do I have? I have 10,000 moles. 10,000 moles of calcium carbonate has been given to me. 10,000 moles of calcium carbonate has been given to me. If 10,000 moles of calcium carbonate has been given to me, how many moles of calcium oxide to be formed? Same, because it is ratio 1 to 1. So, same. So, I say 10,000 moles of calcium oxide will also be formed. Will also be formed. So now I have 10,000 moles of calcium oxide, but they're asking me for the mass. What mass would be? What mass will be formed? So I can convert this to mass using the same equation, N, which is 10,000, equals to, given mass, which is what I'm looking for, divided by molar mass of calcium oxide. Calcium is 40 and oxygen is 16. Calcium oxide then is 56. Of course, 56. So I'll again cross multiply, use this to multiply this, and I get my mass of calcium oxide that will be formed to be 560. 10 times 56, 560,000 grams. 560,000 grams of calcium oxide will be made from 1 ton of calcium carbonate. This is easy. Now, let's continue with the question. They said, what mass of water do you need to add to that calcium oxide? What mass of water do you need to add to that calcium oxide? Of course, to know the amount of water we add to it, we already know. Now, we are no longer concerned with this. We already solved that. Now, we are concerned with these two. I now have, we are concerned with these two. Now, I'm no longer concerned with calcium carbonate. Now, I'm concerned with calcium oxide and water, which is the second equation. Which is my second equation, calcium oxide and water. This comes in my second equation. I now have this. I already know this amount now. I know this amount. I am now looking for how much of this I will add. This equation, is it balanced? Yes, 1 calcium, 1 calcium. How many oxygen? 2 oxygen, 2 oxygen, 2 carbon dioxide, 2 hydrogen, 2 hydrogen. It is also balanced. Let me take this equation to the other side. Can I clean this now? But I will need something. I will need this final answer. Okay, I got 10,000 moles here. 10,000 moles here. So the next equation now is, I want to react these 10,000 moles of calcium oxide I formed. I reacted it with water to give me calcium hydroxide. Equation already balanced. So if equation is balanced, that means every 1 mole of this must be reacted with 1 mole of water, because 1, 1, ratio 1 to 1. So if I have 10,000 moles of calcium hydroxide, I will also react it with 10,000 moles of water. 10,000 to 10,000. 10,000 10,000 here. I also have 10,000 here. So I have 10,000 moles of water. What do I do with my 10,000 moles of water? What do I do with my 10,000 moles of water? What do I do with my 10,000 moles of water? my 10,000 moles of water, I now look for the mass because they are asking me for what mass of water do I need to react with it. So I add it to, so 10,000 moles, I add my N equals to M divided by MR again. So I now have 10,000 equals to, I am looking for mass, and water is 18, MR of water is 18. I cross multiply and I get my answer to be 180. So I have then mass of water that will react to be 10,000 multiplied by 18. This is equals to 180,000 grams of water that I need to react with calcium oxide. So you already see how it can happen. Something was produced here and it is now used here. So you can do the last step now, which says what mass, how much calcium hydroxide will you now produce? Of course, this is easy now. How much you now have to deal with them. You now have to deal with now you do not have to deal with this. You can use any of this one you know for this, any one which you want to one also, and continue solve the same way and you will get that quickly. I think time is against us now. We still have some questions, but we continue to solve those questions in our next class. Okay, we have some other questions. We continue to solve them in our next class. I will stop here today because we solve some questions and we'll solve more questions in our next class, and that class may be a little shorter than this because we have fewer questions left. So go to your questions, go down. You have a lot of questions to solve now. You have a lot of questions. The more questions you solve, the better you become in quantitative chemistry. Good day and God bless. And before you go again, do not forget to send me your email if you have any question, and I will reply you back with a custom made email, which is a video just for you.